Unique today. Because anybody joined us, we may back up and start over a little bit, but for now,
Thank you.
uh, I'm gonna go ahead and share my screen if I can do that, and then I'll try to tackle a few of the questions that have come up. And I feel this is fair because honestly, Tuesday and Saturday, Abbas, you were the workhorse. You did most of the sessions and most of the discussion. You did great. So I don't mind taking some time today. But you should see like the globe up here. If I want to add a new observation, I put in the moon in here and I put a search, and I don't see the moon. But oh, there it is. If you toggle around on the hours, it does tend to come up. I can rotate the globe and see where it is. So honestly, right now, this weekend is like the best time to image planets because they're all on the other side of the globe. But if I go back, I go back to days. Okay. But I'll rotate the sun around. And so there's the sun. So everything that's up during the day isn't showing because we couldn't observe it anyways. Once the sun sets, there they are. All the planets are up. So some shorthand we know is that each of those hours is an hour hand, it's the width of your hand. And so all the objects are moving across that distance in 1 hour. So an hour later, they'll be like Venus will be over actually close to where Saturn is in another hour. Everything's going to move. And this dark line is the ecliptic, which everything's rotating around. And Mercury is actually popping away from the sun now, but it's too close to observe. Saturn's too close to observe. I think Neptune is too close because they're basically about 2 lines or 2 hours behind the sun. And each hour is about 15 degrees, 360 degrees divided by 24 hours. And I have been able to capture Venus because it's right outside that cusp of being far enough from the sun to pick up. If the moon was in here, though, the moon would completely saturate the sky to at least 30 degrees out. So anything that's closer than 30 degrees, you just won't be able to image it very well. And there was an observation actually in Stellarium. I don't know if I go to Stellarium if it'll show you, but we'll look at Stellarium later. But the moon was right next to Mars, and so it wouldn't let him observe it because you couldn't get it anyways. So right now, everything's on the other side. Mars is really easy to grab. Jupiter is easy to grab. Uranus and Venus is more difficult, and the others are just sliding too close to the sun. Okay, so let's see if I can do this right. I'm gonna go to AfterGlow. So I click on the Open AfterGlow, and then I hit Login via Skynet. So I put my password in. It's really quick. And then I'm gonna pull up one of these images of Mars. So how we'd normally get into, I've already opened them, so they're over here. But normally have you been doing this? You go to the files, go to Skynet Robotic Telescope Network, go to User Observations, and then I pick the object I want to look at. Like if I'm looking at Mars, I'll open it up. And if you'll notice, I'll go back one. So up here at the top is our little cheat bar. I'll go back to User Observations. And you notice I took like 5 exposures and 4 exposures. And what I was doing was trying different exposure times. So that's what I'm playing around with. And I'll try to post that through this spring as far as what they mean and how they came out. So over here, I open up the Mars. It shows me my exposure times. And it adjusts these for the telescopes automatically. So I don't remember picking these times, but once it puts it through the telescope, it'll adjust it so it's comparable for whatever telescope you're using. That was kind of nice. But you notice I went as short as 0.12 and as much as 0.25. I think in the other file, I went all the way up to like 0.55. I kept adjusting my exposure times. And Abbas and I have more time than you folks have, so I didn't mind eating some credits on this. So if I try the short exposure one, I just double clicked on it. I think that should do it. There it comes. Okay. And I don't see anything yet. So I'm going to zoom out on it and see if it doesn't show up here. There it is.
Uh,
Okay.
yeah.
And then I can zoom in on it, bring it in and center.
And
And
you
it's
you
looking
can put you can use the zoom fit when you don't see it the picture. Yeah, that one.
is that
If
one?
you yeah, zoom fit, zoom to fit. When you do that, it brings it up on the center normally.
Oh, nice. Okay. And then over here, I can change it from faint target default. So I go to faint target, looks like, yeah, ain't gonna work. Default looks like that. And then bright target, which is what this is. And I'll come back. Sorry, I'm trying not to make everybody dizzy here. Let me zoom in. but I can see some pretty good features on Mars already. This isn't looking too bad. And what I can do to make this a little bit better yet is I come down here to the saturation level, and if I increase this right up to 100%, see how it's adjusting there. Oh, actually, I'm going the wrong way. If I go bright, smaller, it's bad. If I go darker, I can start to see more of the features. I can see the poles, and this tells me my image of this Mars is rotated. And on the right, we have all these other little features here. So this file right here, as pixelated as it is, we can export that as a JPG, which you know is compressed files. If we kick it out as a fits, it's an uncompressed file, and it has the information which shows up over here on the right. So I hit show file info. All this stuff that's popping up under that eye is all the stuff that's layered behind the fits file, that stuff we don't normally see. And this tells me like what filter, what exposure length. This was actually one that I wanted, the telescope up on the mountaintop. And it tells me more detail, a lot of details about it. If I hit the first one, this is the one I was using to adjust. And it shows a lot of information about the pixels and all that. I'm gonna go ahead though and go down to this fourth one. So this is a little trick, and this was something I had to use in a previous life when I was doing research fiber optics, is you click on one side, you get this little dot. Now when I come across here, if I look at this profile, it really looks nice. It shows me that bright spot where the ice is reflecting off the sunlight. And then all those little bumps are showing us the features across the Mars, the dark and bright areas. When I look at that, I can see that nothing here is saturated. It looks really, really, really nice. Okay. So that's probably not a bad exposure, although it's capping out a little over 2000. Now, if I do another image, I think, I'm not sure what the time is on this one. And let's get it. All right, hit center. Oh, I like that feature. Thanks, boss. I come in on it. Let's bring it over. So this really is more than you need to know for these lessons. But I can see that looks a little bit different. And then when I check this, when I do a scan across it, I can see that this actually must have been a very much shorter exposure because I'm tapping about 1500. It still has really nice profile to it. But it doesn't have as much contrast. It won't have as much contrast because the numbers are smaller. So I figure you'd understand that. Now, if I open up Venus here, let's do this again. So center. Okay, zoom, 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 zoom. This was the one that really triggered me to do this because I got to Venus and I'm like, I want to see it. I want to see the features. I want to see some details. And I can max this one out. So I go back to the first eyeball, hit the eyeball. Okay. I'm going to max it out and see if I can't get it. That's 100%. It still looks like it's completely washed out. So I come to the plotter and I click, and I can notice how much light there is around this planet that's it's blooming from the planet. So that's an artifact of the CCD. It's trying to suppress it. It's just too bright. And you can notice when I do this, look what happens. So you get the hat across there. I'm losing resolution. I lost the resolution. I cannot see surface features. So I try to do some really short exposures. I'm gonna go back through this. Again, this is more than you need to worry about. I just want to make sure you're aware of this. Okay. And a question somebody got was, so nice thing about, let's have these open across the top, I can just click from one to the next, is we know that this doesn't look like the magazine quality images. And what you'd have to do though, is if I did take, say 10, 20, maybe 100 images, and I were to stack those, yeah, that's when your details would start to come out. So again, we don't need to do that. They're trying to, right now we're trying to learn how to get the planets and just be able to do it, then do the moons and all that kind of stuff and work with it. But I had you in mind when I was doing this. I thought, does that make sense to you what I was doing there? Okay. So I'll try to do is, time permitting, try to look at some of these objects and try to give kind of a span of, what is the best. And the real lesson of this is as we're going through this, Abbas and I, we're trying to get better at this ourselves. And if you figure things out, just share them with the group. And I know Christian on it was yesterday or Tuesday. He's already working on some stuff too. Let's try to share those out um, through the chat so that everybody can kind of learn from each other. Any questions on that? That's quite a bit. Are you muted? You're muted, Avery. I didn't know.
Oh, wait, can you hear me now?
Yeah.
Yes.
Okay. That made sense. Do you know where the stacking function is on Afterglow?
Uh, you muted, John.
That's me. I don't think Afterglow will do stacking.
Mm.
And I did something came up that they're using another program that there's astronomers are using another program for stacking. Because I did a real quick search, and that was just a quick search. I didn't spend much time, but I had a question about something else we were doing, and I looked it up, and I forget the name of the program. I'll try to find it. That if you're
Mm.
curious on learning stacking, which I think you would be, that's one way to do it. One nice thing about though the Skynet, and Dan kicked this out, it does dark subtraction and all that already for us. It's amazing. It'll do a lot of corrections for us. And you are okay. You understand how it takes a dark field and the dark noise and it kicks that off. Any question about that? Are you okay?
It's background subtraction, right? Like kind of what we did with APT.
Yeah. Yeah. So, yeah. Yeah.
And
Boss,
yeah, and
you
on the stacking, I have to double check with that, but I believe we need to use another software to do that. And mostly Afterglow is focused on the pictures. At this session that we have, as what they call OPIS, uh, as like professional astronomers, we just do black and white. But when you're gonna go to the colorful picturing, that's another course. Next level after this is called MWU. It is multi-wave universe. That means that you're gonna go to the spectrum and get the result accordingly. If we can able this is second course that is developed then, but it is not well documented like this. You see here on the WebAssign, you have lab 1, 2, 3, 4, 5, but that MWU doesn't have, you can do it stacking over there as well. And the colorful scattering, it's very good, and you can identify surface features on that. But that is kind of right now on the Word format. It kind of some instruction on the Word and still developing. I'm taking that course this semester with the Dan and the others instructors. But if we can make it the next time, the next session on the next semester, I think that's gonna work. But that's a good question. You made it. But on the other hand, this in addition of the MW, as I mentioned, OPIS is very well developed. The MWU is in the development stage, is not completed yet, and Dan and other colleagues we're just working on that to make it work. But we had some instructions that I can start doing kind of fun things. For example, we take several pictures on different colors and filters, and then combine it together and look through the kind of assigning different for example, nitrogen, oxygen, different colors and things like that. That is a very fantastic job gonna be. But the other thing is that we can use the whatever picture we took it on the other stacking program like Sharp Cap or Astro Image or what to call it, Plexite and other ones, as you know, or you may have it. But for now, we are not focusing on the stacking on the OPIS, and because I don't think this has the capability Afterglow to do all of them at this stage. But because our focus is going to be black and white and only single pictures to see how we can come up with this basic things on the beginning, basic operation of the evaluating the object accordingly. Thank you. If you wanna, John, if you wanna, I will go over some other items to describe it on the post-processing.
yes. I was thinking like you went through the Jupiter and the moons. We can make
Yeah, yeah,
sure
yeah.
that we're how to
Yeah,
find them.
let me shared my screen.
Yeah.
Let's
And while he's setting that up, yeah, Avery, what I was running into was the DS9 program. You know, we have JS9 too for the Chromebooks. But I had a mismatch of images. I was trying to do a tricolor in DS9 and my images weren't aligned. And I found out in DS9, not that I know of, you can't adjust the position, which was very annoying. You have to do a whole process to use DS9 to create tricolors of your own stuff. And I was looking at what people were using instead, and it came up that they're using some kind of stacking program that was allowing them to move stuff, but the DS9 will not do it apparently.
yeah, let me see if you can see it, the picture. I have it here. Okay. Do you see the picture of this is kind of web assign that we have and the lab one? Do you see John and Avery?
You see Stellarium.
I see Stellarium.
You see it?
Stellarium.
Yeah, yeah. Oh, you see a Stellarium. Okay, let me unshare it and share it again and make sure
As he's doing that, so real quick, Avery, Mars being close to the moon, you understand that issue, right?
Yeah, just the light from the moon getting in the way. Yeah.
RA deck, FITS files, you're okay and understand what FITS files are. Um, ecliptic, Okay. Just make sure we don't miss anything.
Mhm.
and in here, hopefully you see it, the Skynet. I opened the Skynet at the moment. As also John mentioned, for the post-processing, we're gonna go click open AfterGlow. When we open the before going to the AfterGlow, I wanna emphasize another item, as John explained it very well to identify those. There is also another option exists on the observation. When, for example, this is one important item, this moon separation that we have here, you can specify 60 degree or you can adjust it 30 degree or whatever you have. For the except moon, you have to be minimum 30 degree or 2 hours the difference between the object and moon that, as John mentioned, we are away for that. And we can take this one and put it on the program Skynet itself to do that. We don't have to worry about or finding the moon or do, although it is better to do that. But there is a capability that one, for example, if when you assign here 60 degree and submit the observation and picture, it gonna automatically for 10 or 12 telescopes, it gonna calculate when it is that 60 degree happen, then start gonna take a picture. That might be one day, might be 2 weeks, might be 2 months. Therefore, that may takes time because of this kind of condition of the orientation of the objects on the sky. And that's one key item that we can use it as in here. When we go to the observation in here, for example, I will go Jupiter's moons. As you see it, when you click here, you see graph, but you don't see anything here. We have to use this bottoms that we have here uh, to bring it on the field. The things that we have it, I remember this one as export a JPG, whatever you see it taking by the picture from the Skynet. And this is whatever uh, download viewer snapshot, whatever you see it here. If I click it here, it's gonna show black. But to bring it sun, we can zoom it in or zoom it out or use this one. This is brings on the center mostly. As you see it, brings the center. We can move it around and play with it and again zoom it in and make it enlarge it. And so when you do that, when I click here, download viewer picture, it's gonna show this one. But other than that, if we're gonna click the JPG, it's gonna show this one. Therefore, for submittal, there is a submittal on the labs on the web assign. It's recommended to use these features because we wanna see you bring it here and you get, because if you bring it in front, you can see it better on this consideration for the observation and other activities that you're gonna do. Therefore, I recommend to use the zoom to fit, and also there is a reset zoom exists here. You can use it as needed. Sometimes it goes up and you have to bring it on the middle. And then probably you see at the 2 or 4 moons. The reason that I'm saying when you enlarge it, you see this is not very sharp circle, might be 2 moons beside each other or 2 moons beside each other. And therefore we just bring it back in here, and uh, then and here there is 3 icons. We can use it more often. If you want to see bright object among the Jupiter and the moons, Jupiter is more brighter than those. When we click this one, it's going to show our Jupiter very well. Therefore, we can enlarge it and take a picture and submit it on the lab. And if you want to see the, let me zoom it out. If you want to see the faint object also, we click this one and zoom it out. You see it, it's very noisy here in here. Therefore, you can come and on the bright object, when you see here, you see this is about 100. Saturation level percentile is about 100. Be using the percentile on this kind of statistical future here. You don't need it to worry about that. And if you know, or if you don't know, that's more important is that we have to make sure this bright object normally very close to 100, and faint object is about 90, between 92 to 95. What we do here, we just increase that saturation level percentile. You see, gradually the noise is gonna go disappear. Most of the noise on the background is disappear. You see 99.36, 93, 99.37, and again it disappears. And here is a little bit better background picture we have from the dark side. And if we continue this one, we're gonna reach in a point that the moons is going to disappear. Therefore, because we're going to take the measurement and understanding what the moons and the distances and things like that exist, probably we can play with it a little bit to bring it both of them on the subject, although we don't see it futures of the Jupiter, but it is not important for us at the moment because we're going to have some measurement on this consideration. If I see it, I want to emphasize on 3 items. This is a main item that shows they will call it here display setting. This is the main menu of the picture. This is the arrows for the zooming and zoom out, and this is kind of information giving about the coordinate system and some other features on the pictures and the pixels and things like that. We don't need it to worry at the moment about those. Another thing is important. When right now I'm gonna show you how we're gonna identify this object and how we're gonna take the measures. We can might be the orientation may not be the same as the orientation that we have in here. The reason is that let me see. Do you see the picture here? I show the Mars. Sometime the Mars should be like this. It's a polar cap on the north. And sometimes you see it reverse, the diagonal reverse it. Here, the big dark area on here and here on the left side. And sometimes you see it this side, and sometimes you see it, the one that John showed, it is on this side, the polar cap. And the reason is that because of the different mirrors and the optics that we have on the telescope, it may rotate this one. Normally for the stars and the galaxies, we don't care about those because it's not orientation for us. It's important as long as we know we looking through the object on here. But back into the what to call it in here, as we see it in this consideration, we can rotate. For example, if you want to flip it, you just flip it up and down. You can mirror it left and right, or you can rotate it 90 degree in each click. Therefore, you can play with this one to match with your Stellarium view that you're gonna have. And the question comes that how you're gonna check the Stellarium. Then the second item is important here. One is the one here, it shows I. I provide the information about the data on the picture. Pick number of the pixel, number of the arc minutes, what time it started, what time the center time, and what the telescope is using, what the observatory is observed. That is important because when we go, you see the web assign right now? And the web assign, for example, we're gonna come here. In here, when we have observation with uploading the pictures, we're gonna identify observation sky number. What's the sky number? Sky number is here. When you look through it, if you wanna take a picture of the moon, this is a number that you have. Therefore, on this lab, this number is the one that you're getting from Skynet and showing us what ID you're using. And the next item here, if we go down for the planets and so on, we're going to have more data. For example, for the Venus, we're going to say if it is observable or no, yes or no. Here, what telescope used, and what telescope we can check it. For example, let me go back to the one that I had it. Here, the telescope is using prompt 6. Then I provide here prompt 6. For example, this was Jupiter. This is yes, Jupiter. Universal date. Universal date. We go back here. Universal date. We have several date here, but I think all of them gonna be the same. Sometimes they are different between start and end because it's start before midnight and after midnight the day is changed. But it's not important which one is we're providing, but it's better to provide a center time always. For example, here the picture taking when? September 17, right? 2024-09, and this is a GMT or UTC, Universal Time Zone. Therefore, we have to remember this one, September 17, and we go back here and put the date and time on the Jupiter here. Then Universal Time, back here again, Universal Time is 07:45:25. It's not important to go much on the second, but as long as you provided the measurements for the minute is good. But here, because it's asking for us hours, minute, and second, we have to provide here 07:45:25. Then when you do that, and then measurement angular diameter. Okay, then we go back here. For that angular diameter, we need to go to the next phase. This is a plotter. This fourth option on the right, plotter. Then we have some items that here, normally we do the synchronized plot axis, and then we just click by the mouse on this side and this side. And then it shows us the graph of the light. Although I see it very bright, but this picture shows very meticulously it varies. It's not similar at the cross section of the moon. And that length of the angular, well, how much it is? 51.052 arc second. And we put here is arc second. You got what number you're gonna put? 510.052. Then you're gonna provide same thing here on this item. And here they provided some example how you could format of the writing the object. For example, here you have to use the slash, here double dot you're gonna use, and here you can use it 1 or 3 significant digits. For example, on here 3 significant digits is 51.0 only. But you can put more if you need it, but the minimum you need to put 3 significant digits. Then, okay, let me go and check it with the one that we have on the Stellarium. I go to the Stellarium on my desktop. Several things is important to consider on this Stellarium. You see the Stellarium, right? Okay. Here at the bottom, some versions might be different, some version are local.
We're still
In
seeing
here,
sky glow.
pardon me?
We still see sky glow.
Yeah,
But
yeah.
afterglow is up, not Stellarium.
Oh, it's not the Stellarium. Okay, let me stop it and show it again. Probably that's
Any
better.
questions on any of that, Avery? You doing okay?
Okay. Then here on the Stellarium, is several important items considered. We normally, you don't want to use the Earth futures. We delete those. We don't want to use the cloud and things like that. And then we see it all the items that we have it here. And important is that here is that we show the what to call it, telescope that we have it here. And then probably we can use the grids as John described it, but it's become too much at the consideration. For now, we're just considering those minimum items that we can beneficial for us. And then we're checking the, what to call it, the observing one item that we needed. For example, let me check, no, let me look through search on 2024. And let me see. Mm,
Yeah, you're using the desktop version too. That's the
Yeah,
full
it is
blown.
sometimes the desktop version is creating the, I'm not get too used to it with desktop and sometimes create issues. But anyway, I will try to see Jupyter. Uh, s- sometimes it's not very friendly to identify the object. Okay, here is better. Jupyter. Okay, search Jupyter. Okay, then Jupyter brings on the center. And then I have to identify the time. For the time here, we have to specify exactly what time of the consideration is that. Here, you know that this is kind of astronomical calculators or configuration window, find the object, and other things that this is the time. And the time zone that we're going to check is based on the UTC. We have to change it or time zone to make sure that comes with the UTS here. On the first button that we have here, we just go locate the UTC probably. Sometimes it comes with the Greenwich. Sometimes I think I'm just spending this time to make sure that we get the correct one because this is very, it may take time on the beginning, but gradually become, or you can search here, I forgot. You can search here GMT or UTC or Universal. No, Greenwich. Greenwich. Yeah, here is the Greenwich, and then therefore it's gonna be set up based on that. Return the observation. Okay, that's the one that we already choose it. Make sure I use the current location. No, get the location from the network. Yeah, that's the one that I choose. Therefore, right now we go to the time. Okay, what time was that observation? 2024, November, sorry, September 17, right? You may need it if you are not having two screen. You may write it down on a piece of paper to make sure that the times are correct. This is the time was 7, I think 7 in the morning, 45, 25. The second is not very important, but I will go to get close. Okay. Then I choose again Jupyter. I set up the time zone, I set up the location, and Jupyter right now is on the setup. Okay. Then I close this one and bring it, zoom in. Okay. As you see it, you see on our picture, two moons was close by on the Jupyter. We see it on the picture. Therefore, it shows that this two moons, one of them is Ganymede, one of them are Io. Therefore, if we go again, check it to make sure that time is still the same time and the zone is the same time. Always, you need to do several times to check it, make sure that by accident you don't click something that make it different. We may not able to see other small moons like this, but we can enlarge it like this. And if you get the if you want to get the information, you can click it on the Jupiter here. As you click on here, it gives you many different information. For example, it gives you one of the items that is important for us, the angular diameter. You can provide angular diameter in the one of this. There is too many information you have to get to use. Yeah, here's the face angle. This is not important. Elongation and hourly motions and okay, apparent sidereal times, and then can okay here it shows that apparent diameter uh, and this is the actual kilometer diameter that is showing, and another one is that here that's angular diameter that we have. How much it is? 40.48 second. Do you see it? 40.48 second. Therefore, we know that this is one of them Ganymede, one of them Io, and then we close this one. We go back to the our observation. Okay, how much we have here? 51.52. Therefore, how much was that? 40.48 second. You see a big difference here. That big difference might be for different reasons that you can provide here. For example, when you put your here your arrangement here, how much was 50.0, 51.0. Then you describe here what was the you will what you understand based on that. Sometimes, for example, here there was some kind of information suggestion that provided for you. You can provide it here. And also same thing on the procedure for the Stellarium that we went through it. You check the UTC and the other information, and then you put angular diameter of the uh, Stellarium. How much was that? 40.48 second, but ours was something else. When you put this one, it calculates the percentage error accordingly. And you can calculate it yourself here and present your calculation on here. But this gives you some information. Discuss what the source of the error was. For example, the source of the error might be due to the human error. We don't call it human error as kind of error because human error can be worked out and make it work. The errors that we have either for the calculation or measurement skill. The reason is that, for example, here, I may click from here to here, I get a slightly different reason, and I get from here to here, different one. And if you enlarge it, you see it, you make it pick there is a difficulty to pick the age of the Jupiter here because we don't know very clear observation here. The other option is that you just click on the, what to call it, the bright object here, go to here and say bright object, enlarge it, and then you do it again. Come here and take it. You see the measurement that I took it? It goes far beyond the actual diameter of the things. Because of that, is greater than 40. But when you click from here to here, see, it comes very closer to 40. And if you come here to here, it's slightly better. But you know, those also may not be, this line may not be go from the center of the Jupiter. That's kind of things that because of the measurement and kind of various object that we provided as a kind of measurement for the object, angular diameter, that gonna gives us different numbers. And you can discuss the this kind of errors, and you learn might be its error might be 3.3%, 5%, 6%. It's very normal under 10%. But sometimes for the other faint object like Uranus or Neptune, this percentage or dwarf planet, that error percentage might be 500%, 1000%. You don't uh, what to call it, discouraged based on that. Because the reason is that for many different things, the objects are very faint and we cannot easily see the, what to call it, the diameter of the object or size of the object. And based on the precise measurement that Stellarium or other scientific tools have. And therefore, that gives us some idea that not always all the measurements are accurate, but we go closer to the reality based on the more scientific approach that we have. This is kind of very small uh, kind of view. I want to touch base with you on that you can do measurement. And you see it here, the picture here, it shows very good. For example, in some area, when we come here the start is very dark and we get here is light and then we dim it up because of this atmosphere, then light it up here and then dim it up again and come back here and dim it up at the end. Therefore, this 1, 2, 3, 4 dim is regarding for this 1, 2, 3, 4, and exactly show the same one. If we do it differently from here to here, the dims are going to be different. And also, if we do it from here to here, we don't want to see any dim. Why? Because all the line is aligned there, bright portion of the Jupiter. And that's the very cool things that this graph and working with the Afterglow, it shows us, although we cannot see, as John mentioned, very beautiful magazine or social media pictures, but we can do it very good things from this, although it's not very precise and beautiful. Any
Boss,
question?
could you scan a little extra beyond each side? So go a little outside. So yeah, a little bit out and then go across. One thing you might think about doing when it goes to diameter, this is a nice way to approach because now you can see where the edge of the planet is at if you're going for radiuses. So I noticed I was trying to go edge to edge, and I
You
think
know,
you missed
yeah,
information.
exactly. The age to age is very difficult. You see, because this is gradually it moves. Probably there is some halo, and also there is some rings around the Jupiter. Also, we have or some other features. Therefore, it's not we don't have very sharp up, and we have although it's very close to the 90 degrees here, but it's not very complete. It is continuous graph. This is my point of view. I don't know. If we choose at different things, for example, we can choose the centroid. We can use from age. When we do from age to center, like here, it's gonna be how much it is here is 0 point, sorry, it takes a 0. And the problem is that I have to click this one away. No.
Another thing you can look for at this point, once you have this image of the Jupiter is nice and sharp, a reason to do this would also be to look for moons. Sometimes you won't see the moon because Jupiter is so bright, but you can see the shadow of the moon on Jupiter. And it's a neat way to pick out an extra moon.
Yeah. And also right now I check it from center of the disk to the edge. It's gonna be 18 arc second. Times 2 is gonna be about 30, 36 or 38, closer to 40. Therefore, that's another way of the measurement. We can use it accordingly. And as you see it here, this graph of the light, it shows some other features. And if another thing I wanna emphasize here, if we go back here and make it observe the uh, faint objects, slightly make it this one, 98, 99.34, something like that, or 39. You can enter the data here or just click here as comes closer the one that you needed. Either way is possible. Here is better. Then I enlarge it, okay? I know this, one of them is Ganymede, one of them is U. Therefore, for marking up, we can use it here, the options that we have. Let me see on here. No. Yeah. Okay, here, the one that we had it here. So let's see, marker label. Then on the item here is the hide source code. Let me see if I correct it. Choose the correct one. Might be on here. Oh, no, you're here. On the third one, I forgot. This one is the for the marking the object. You have to use this one, custom marker. For the custom marker, you just have to identify here, click here, and planet centroid, both of them. For example, you click here, then you label it, Ganymede, and it shows the Ganymede here. And then, if you wanna make it radius larger, you can do it, or orientation, change it to orientation, location of the object that you want to see. You see, it move it in a place that is better. And then you click on the next one. Okay. Here, sorry, I clicked 2. I have to redo it again. And redo it again. Okay. And you have to wait a little bit to make sure that the click it comes, and then the box is comes for the providing the data. First click is circle the object, and second click bring your table to, sorry, I misspell it. Uh, uh, and then it's okay. Then second one. First is the click is bring the circle, and second one label IO. Done. Therefore, you have identified those, and then next thing you need to do, you can identify this one as well if you need it. Jupiter. Radius.
Okay.
Make it a little bit here, Jupiter. Okay, that's it. Then you just save it as a kind of by this icon. When you save it, it comes here. And this is whatever you submit to the lab on the observation. Here, when you provide here observation, it gives you a location that you're going to provide this data and identify the object that you're going to share it on the screen. And that's going to be basically a kind of a little bit step by step. If you go and familiarize yourself with that, it's going to be very helpful to the progress of the identifying this object. Right now, I can, for example, make it bigger to make it more observable, but that's basic information that we needed to provide on the labs, on the post-processing of the data. And also other things you can, for your curiosity, you can consider accordingly. For example, if you want to check the distance between the moon and one of the Ganymede and the Jupiter at that time, click and here to here, you get the observation about 90 arc second, or from Jupiter to the Io is 124, or between Ganymede and Io. It gives you the graph and also the sizes. And that's we're gonna go over here, and we have many other options that we can check it, like other activities on the lab 3, 4, that eventually we're gonna get to know those. I hope I didn't overwhelm you and you catch the points fast, not like us very slowly. Sometimes I forgot also. If I don't do back-to-back review, I forgot and I had to click this and that to make sure that I get the right answer at the end. Any question?
I think that makes sense. Thank you.
You're welcome. John, anything you want to add?
That's a nice job, especially adding the labels and stuff. That's so cool. And when you change the resolutions back, the labels stay there, which is really cool. I like that too. Then we can save them out. Do you want to talk about the grace period is over for the WebAssign, and Avery, you and I talked a little bit, but it was really a surprise. I thought everything was free from the Skynet through the WebAssign to all the videos, and the videos still are. Skynet still is. The WebAssign isn't. It's a $65 fee to have that. And so we were trying to figure out how to resolve this because we didn't know either. And it just wasn't communicated forward to boss ourselves. We didn't feel like we should put this on everybody when we told everybody it wasn't a charge. So we are providing a couple options as far as how to go forward. One is if everybody just completes the lessons and stuff, you still have the videos, which gives links, and I just put all those on GroupMe as far as a link on that and the links for all the settings. We'll try to get all that in and anything else needs to be done so people can complete it. And then if you complete all the assignments, we'd give a certificate. The other option is to go the WebAssign route, and then you'd get a certificate through UNC Chapel Hill to Professor Dan is what that would be. But just, sorry about how that worked out. And that's, Boss, you want to add to that?
As I mentioned, if you need a help for that $65, I'm offering to help. You can send me Venmo or PayPal or whatever is comfortable. I can pay you because the reason only between track and A and B is that on the B and A, both of them you learn everything same. But on A, you're able to the one that he showed you, for example, let me show it to you again on this picture. When you have on this picture, when you want to go here, you don't see any of those to add kind of data or things like that. That's gonna be only for track A. You cannot do, for example, this kind of calculations or put the data and get the grading and things like that. Grading here does not means that, for example, on the lab 130, if you get, for example, 120, you are A, or if you get 60, you are D, or you failed. No, it's not like this exists. This is not like a regular course on the university or a school. It means that you learn how to do that. Sometimes when it is a lab, for example, lab one is 134, uh, because you said here Venus is not observable, Mars is not, Ceres is not, or the others is not. Always you're losing 50% of the grade. This is kind of not a regular course, but in a way that make a joy and kind of similar way that a professional astronomer does, and you engage your kind of encouragement and also courage to do activities on this like professional astronomers and learn practically what astronomers actually do. And that's because of that, you on the track A, if you don't pay it for the what to call it, getting the web assign, you are not able to insert those and access web assign anymore. But you're gonna have access to others. But I'm just saying that I'm just without any hesitation. Because this gonna brings back the learning for everybody, and I didn't know myself that gonna be that charge exists and offering that kind of help to help you out on that. There is, I mean, I don't know how to express it. I'm not very good in English to say it that way, but this is honestly the one that I'm thinking that I will express it on the right way that everybody come on this course and use it WebAssign as needed to learn something. And when you learn something, I learn also something. Therefore, it's not, it is all multi-way. It's not just one directional.
Yeah. Somebody actually asked us, is there a major exam at the end? No, there is no major exam at the end. So it's
And
all about,
we don't have midterms or
no,
exams.
no, thankfully not. So any
And
questions?
also, yeah, one question. I also the grade is also assigned directly by the web assign. Although we can, John and I, we can change it a little bit, the grading things like that. But most of the automatic grading done by the web assign based on the whatever the programmers are developed. Any further question?
No, I think that was really interesting. I had no idea about like the centroid stuff and all that. So,
Thank
or the
you.
plotter. So.
Thank you, and I hope you have a wonderful rest of the day and see you next week. And with good news about the new observation and new incitements of the sky. Hopefully, we have more clear. How about your side? Is clear on your side also?
Right now it's
Here,
pretty cloudy, but
no, here become after several week, I think 10 days of the rain, it become a bright sky right now. Hopefully, good. Okay,
There you
enjoy
go.
your day and have a wonderful evening.
you too. Bye.
Thank
Thank
you.
you.
Bye bye.